What would it take for progress to occur, for man to ascend, for infinity to begin? Only a bold guess that things could be better, and a relentless perseverance to make it so, fueled by blood, sweat, and tears, all while staring straight into the deadliest beast of all, parochial social misconceptions, and fighting back for the only sustainable way to live is to progress. This was an excerpt from the worksheet of The Beginning of Infinity, and today I'll be reading my summary of each chapter with some side notes. The worksheet has 280 questions with answers for you to challenge your understanding and learn main ideas of the book faster. You can find it in the show notes. A little bit about me. My name is Mark, and I'm a 20-year-old who paused university studies to self-educate for a year. In my first 4 months, I've studied David Deutsch, epistemology, quantum physics, computation, and evolution. In the process, I noticed that people take years to understand David's books. This is a problem, and by then I knew that problems are soluble. Hence, I spent hundreds of hours creating a worksheet for each book, and as a gateway into them, the podcast you're hearing now. In the last 8 months, I set out to learn software engineering through MIT and Harvard online courses while doing coding projects on the side. Basically, I took Scott Young's project of learning an MIT computer science bachelor in 1 year and slightly tailored it for my needs. This is my briefest summary with the full story documented on my website. That is markkagac.com. Now, last disclaimer before we proceed. My promise is that we'll cover the main ideas of the book and each chapter. But don't expect a detailed explanation for every conclusion that the book defends. This is the best one can do so briefly. And if you want to dive deeper, the worksheet would be the best place for you to go. And mainly, if you notice any mistake or something I could do better in the worksheets or this podcast, please tell me via comments, Twitter, or email. I treat my critics warmly and respectfully, as they are the only way I could improve. Now, on to the episode. First, we'll summarize the whole book in 5 minutes and then proceed chapter by chapter. All knowledge creation is a 3-step process: meeting a problem, guessing a solution, and then criticizing it. This is true for art, philosophy, and math. Since knowledge grows through criticism, we can never claim 100% certainty, as we don't justify or create positive evidence for theories, even in mathematics. Hence, knowledge creation is a journey from a misconception to an ever smaller misconception, from problems to ever better problems. Thus, problems are inevitable. Science wants to understand the world, which inescapably means explaining it. Prediction is a mean for criticizing theories, not an end on its own. Theories are just guesses. We criticize them experimentally or philosophically. David presents a breakthrough in the second one. Explanations must be hard to vary. From this, we infer that something is real if it is in our best explanations of the world. Good explanations are not limited to physical reductionist phenomena. We constantly invoke abstract emergent things, and thus, abstract entities are real. Side note, as they are in our explanations, which is the criterion for what is real or not. Physical world provides a narrow window through which we observe the world of abstractions. Together, they form the reality we are in. Knowledge is a physical force. It can transform the landscape of Earth and much more. Since Enlightenment, for the first time in history, we had a sustained progress. We created knowledge in every facet of life. The only true constraints are laws of physics. Everything they allow is achievable. The only question is how. And knowledge is the answer. And thus, problems are soluble. Are things that create knowledge significant? Well, their significance depends on knowledge power. With the right knowledge, one can bend the universe to their will. Thus, things that create knowledge are universally significant, and thus, humans are universally significant. The other name for a problem-free state is death, and thus, problems are desirable. Optimism is a philosophy that all evils are due to the lack of knowledge, that problems are inevitable and soluble. So progress is unbound and infinite, that problems are desirable, that humans as knowledge creators, are universally significant. So what would it take for progress to occur, for man to ascend, for infinity to begin? Only a bold guess that things could be better, and a relentless perseverance to make it so, fueled by blood, sweat, and tears, all while staring straight into the deadliest beast of all, parochial social misconceptions, and fighting back, for the only sustainable way to live is to progress. And this was the summary of the book, and now we'll proceed chapter by chapter. So chapter 1, the reach of explanations. Supernovas, gamma-ray bursts, quasars, and black holes are all so huge, so inhumane, so violent and significant that we are only left to tremble in awe and fear. It is only natural to perceive us as inconsequential chemical scum. But is that so? No human has ever been further than the moon, and yet, in our small, humane, safe, and insignificant buildings, we contemplate the fate of the universe. How do we know? How could we, so small and unimportant, have access to them, so enormous and seminal? This chapter is about how we understand the world, specifically how science works. Its guiding question is, how do we learn about the world? And its summary is, science is our best tool to understand the world, and for many centuries we had a mistaken view of how it works. We believed that we derive theories from our senses by purely observing the world. We believed we could induce theories from pure observation. We believed we could create a positive evidence for our theories. We believed that science is about predicting reality, not understanding it. These misconceptions are still prevalent, but now we know better. And as a side note, for deriving theories from observations, right, one can imagine you just look up the sky and you see stars. The stars from our eyes, nothing else, seem as small, dim dots. They don't seem as big, hot, but we can understand what stars are, that they're big, that they're hot, that they're actually very dangerous, only when properly studying them, not from looking with our eyes up the sky. And of course, there are more details to it, so I highly recommend to go to the worksheet and read David along. And so I'm continuing. Since Enlightenment, we had both rapid and stable progress that was initially caused by a philosophical revolution. We rejected intellectual authorities and created a tradition of criticism. Eventually, we learned that all knowledge is fallible. It consists of our guesses, which are then criticized to leave the last man standing. We criticize through experimental tests or philosophical arguments. And as a side note, this is of course Paparian epistemology. You can find more on it by reading David. I'll stop advertising it every side note. But yeah, it's a tough text. Highly recommend reading through. Moving on. David introduces a hard-to-vary criterion as a way to criticize theories that are explanatory and impossible to falsify experimentally. He also proposes a criterion for whether something is real or not. Something is real if it is in our best explanations of the world. And as a side note, so something that is explanatory and impossible to falsify experimentally would be an idea, usually a theory, that everything is a matrix. A lot of people are really scared of it. It works like this. So everything is just like our physical reality, but there is one caveat to it. Everything is a matrix. And this kind of additional needless assumption that, but it is a matrix running on some computer, it is a part that is hard to vary. Why couldn't we say, but it is a matrix, and actually half of the world is run on one computer, and the Chinese country had a firewall, so they were run on the second computer. So it's a matrix, but with two computers. And we can say, no, but it's 5, 10, whatever. So this needless assumption of that, it is physical world, but there is one caveat, which doesn't really affect physical reality anyhow, but we should navigate our life as it is true, is needless. It is easy to vary, and thus it follows the David's hard-to-vary criterion. Second chapter, closer to reality. Most of scientific discoveries are made in our small, humane, safe, and insignificant buildings. How can we study and know of something so distant like stars from the proximity of our homes? This chapter is about scientific instruments. We never observe reality directly. The only thing we experience are electrical currents in our brain. yet we don't observe them either. Our senses, with our knowledge, model reality we observe. Popper's thesis that all observation is theory-laden holds for scientific instruments as well. Operating them correctly relies on explanatory theories of how they work and so on. As with any knowledge, such theories are fallible. And I rarely quote David, but this is a great quote, page 41. It may seem strange that scientific instruments bring us closer to reality when in purely physical terms, they only ever separate us further from it. But we observe nothing directly anyway. All observation is theory-laden. Likewise, whenever we make an error, it is an error in the explanation of something. That is why appearances can be deceptive, and it is also why we and our instruments can correct for that deceptiveness. The growth of knowledge consists of correcting misconceptions in our theories. Chapter 3. The Spark. For most of our history, theories of the world were centered around humans. They were anthropocentric. Winter would be attributed to humans with supernatural abilities, and so on. Enlightenment revealed insignificance of humans in the universal scheme of things. Principle of mediocrity and spaceship Earth ideas are its manifestations. But is our situation that mediocre? And is our environment without technologies that hospitable? This chapter is about what makes humans unique and significant in the cosmic scheme of things. It consists of 3 parts. Number 1, misconceptions, principle of mediocrity and spaceship Earth idea. Number 2, human reach and problems. And 3, significance of people. And its summary is: principle of mediocrity claims that Earth is a typical place in the universe, revealing how our past views of the world were parochial. Yet, to claim that Earth is a typical place is to make just as big of an anthropocentric mistake. Nothing about Earth is typical on the universe scale. And as a side note, typical, mediocre thing around the universe is lifeless, no matter, nothing. Here we have water, we have the ability for things to emerge. We haven't seen any other intelligent species. We have a lot of matter. It's very atypical, very dense galaxies and so on. Very unusual if you take big enough scope of the universe. Moving on, spaceship Earth seems to form a similar worldview while claiming the opposite. Earth is a spaceship, and if we're too frivolous with its resources, we're destined to extinct. Even though Earth is not a typical place in its view, it also claims that humans are parochial, arrogant, and anthropocentric, and must be more grateful for the gifts they have received from the environment. Somehow, spaceship Earth accomplishes even higher level of parochialism than principle of mediocrity. Humans have not received any gifts. They were only the one that created them. Humans made Earth hospitable and friendly. The Earth itself had never such intentions. And a side note, imagine you yourself 10,000 years ago, anywhere in the Britain, was just your naked bum. Well, you won't get far. You won't survive probably the night or a few days. Where will you get clean water? Well, you get food. We have created things like canalization, clean water, heating up in the buildings, building themselves, clothes, easy access to food, and so on. We are the one that have created. It wasn't provided by Earth all of a sudden to us from nowhere. Moving on. Humans create explanatory knowledge that helps us to understand and transform nature. Nature is universal, so our reach is too. Yet there are factors that limit knowledge creation. These are matter, energy, and evidence. As it turns out, such features are present in an actual typical place in the universe, one that is dark, cold, and lifeless. Hence, human reach is tremendous, covering most of the universe. As a side note again, because most of the universe is dark, cold, and lifeless, and actually most of the universe has matter, energy, and evidence, even though it's dark, cold, and lifeless. And thus, we can create knowledge there. Thus, if you're just placed on some dark, cold, and lifeless place around the universe, if you have enough sufficient knowledge, you'll be able to retransform it and produce a spaceship which can carry billions of people and so on. So, it is hospitable to us. Moving on. Giving the right knowledge, any transformation that is allowed by the laws of physics is possible. Thus, problems are soluble. Our knowledge would always be fallible, for it relies on refutations, not justifications. And thus, problems are inevitable. Problems are soluble and inevitable, so our knowledge would always be at the beginning of potential infinity. We would never do anything but scratch the surface. As a side note, why it is potential infinity is, again, because we're not destined to create knowledge. We could easily die out. The meteor could hit us tomorrow, or tomorrow when, from the time you hear this, you could hear it before I publish even this podcast itself. In fact, there clearly is a meteor somewhere in the universe that is far enough and we can't see, and it's flying towards Earth, and it's gonna eventually hit us. If we don't progress, we're gonna die from that meteor somewhere far away. So it is only a potential infinity, only if we continue to solve problems and progress further. Moving on. Knowledge is one of the most powerful forces in the universe. With a sliver of it, one can decide fate of the star or galaxy. Things that create knowledge are powerful and must be significant. As a side note, of course, sliver is very subjective and depends on what you're comparing it to. If you compare people who progress 1,000 years from now on, we have only a sliver of knowledge that they have. But yet, if you look in the past, any Greeks only have a sliver of knowledge that we have. So moving on. To understand the universe, one would have to understand humans, our morals and decisions, as eventually we would decide the structure of massive cosmic objects through our knowledge. Hence, humans are cosmically significant. As a side note, just to break down the argument, we create knowledge. Knowledge is a very powerful physical force in the universe because you can transform, you can do anything that is physically possible with it. You can decide that, oh, I want a galaxy which will be made just out of chocolate, and we rearrange the atoms that the whole galaxy is a chocolate atom. I don't know what exactly the chemical structure of chocolate is, but you get the idea. I mean, and then it means that we, things that create knowledge, decide the fate of the whole galaxy, whether it's chocolate or not, and whether it's dark or milk, and so on. And to understand what the galaxy will be, whether it will be milk, dark chocolate, or no chocolate at all, you have to look at how we make decisions, what we think is moral or not. We might say, well, it's not moral to do it in chocolate, we should just leave the galaxy alone. Or we might say it's moral and we need to remake the whole galaxy into milk chocolate or dark chocolate. And you can only explain why the whole galaxy all of a sudden became a one big chocolate bar, or why it has a bunch of chocolate atoms, by following the reasoning, the morals, the explanations that humans have created. And thus you can only explain how the universe develops through humans, and thus we are very important because we're in those explanations. Chapter 4, Creation. As we have discussed the significance of humans and life, we should look at how those came to be. The central questions of these chapter are: how organisms were initially created, how knowledge in organism arises, what is the difference between human and biological knowledge, what is the fine-tuning problem and its potential solution. And the summary of this chapter is: there have been several misconceptions about how life came to be. Creationism assigns all responsibility to God. But then, who created God? And as a side note, so basically this produces an infinite regress. So if you say, well, the Big Bang was produced by God, then you'll ask, okay, but who produced God? And then you get infinite regress. So there must be something else, but it is not to say that we have solved the problem of why there has been Big Bang. Moving on. Spontaneous generation theory assumes that life just assembles from some laws of physics. This might be a complete explanation for some inorganic phenomena like rainbows and rocks, but not for mice. This is because mice has an appearance of design. It is adapted to some purpose, i.e., it has some instantiated knowledge. Lamarckism assumes that knowledge was created by improvements that are gained during animals' life and are passed on to their children. This doesn't explain how the first knowledge or thing is created for it to be improved afterwards. As a side note, so imagine you have the first mouse. What was the father of the first mouse? So we continue. Neo-Darwinism explains that the basis of life is molecular. Genes use organisms to replicate themselves. Evolution optimizes not the good of the species or organisms, but spreading the most viral genes throughout its population, regardless of their effect on organisms. A replicator doesn't have to be a gene. It can be a joke. Knowledge is an abstract replicator. It is substrate independent. As a side note, substrate independent means that it can have different physical representations. So knowledge can be on a piece of paper, in a computer, on a whiteboard, and so on. Moving on, fine-tuning is a problem of why our laws of physics are so well fit for life to arise. Even with minor changes of physical constants, the universe would collapse. There has been many solutions proposed, but none seem to give a complete explanation. Fine-tuning is a problem that is yet to be solved by science. Chapter number 5, the reality of abstractions. We have studied how human and biological knowledge is created and misconceptions about it. But what is knowledge? David claims it is an abstraction, something that has no singular physical form. The central questions of the chapter are: what is emergence? What impact it has on our understanding of the world? What are abstractions? Do they exist? How do we know about them? How abstractions play in our understanding of morality and aesthetics. And the summary is: our world consists of two types of things, abstract and physical one. Denying either would lead to error. Complete explanations usually require both, just as with Hofstadter's domino computer and primality. And as we have previously stated, something exists as long as it is in our best explanations of reality. Abstractions are in our best explanations of reality, hence they exist. As a small side note, what I'm referring to with domino computer, imagine a working computer that works through the dominoes. So instead of just bits and bytes or dominoes, and they fall or fall off, and there is one domino that falls only when some number is primal, it will fall. If it is not, then it won't fall. And then basically the question is, so why does this domino, which determines whether the number is primal or not, why does it fall? So two types of answer one can give. So it's either that, oh, well, you dummy, just look at the past dominoes, they have fallen, so this domino is fallen. But also in another emergent explanation is that, well, it is because the number is primal, so that's why it has fallen. And both of those explanations are good, right? And the explanation with abstractions, it is also good. And in fact, it is more efficient, and it uses the abstraction of math and primality, and thus math and primality exist, or that abstractions are real because they're, again, part of our best explanations of reality. Moving on, we understand and operate the world through emergent abstract phenomena. Emergent because of tractability reasons. High-level simplicity is easier to navigate than low-level complexity. Abstract because we never experience the world directly. All our observations are theory-laden and are just electrical currents in our brain, so there must be something else that we perceive. For we never observe directly electrical currents. We perceive emergent abstractions. Moral and aesthetic theories are abstractions. We can learn about them through conjecture and refutations. Our understanding of theories relies on explanations of factual events and logic, and could be wrong. Hence, moral and aesthetic theories could be wrong. So a small side note on moral and aesthetic theories. So there is some real event that has happened, for instance, the 9/11. And one can be right or wrong about who did the 9/11. So for instance, one can say, well, the government did it. And this is a factual claim about which one can be wrong or right. It's a physical event, right? There is objective truth to it. But then one would use saying, for instance, that the US government has done it to justify or to explain, of course, never justify the troop appearance, but to explain some other moral theories, for instance, that you should never trust government, or that you should do the same harm to the US government as they did to those people, and so on. So the moral theories, they are abstract, but they are based on factual claim, which can be right or wrong, and thus the theory itself that is standing upon the factual claim can be right or wrong. So you can be right or wrong about morality and ethics, which is quite interesting. But again, when they are based on factual claims, and my side note is that it's interesting, what if the moral claims are not based on something factual? Can they be then right or wrong? Chapter 6, the jump to universality. We have studied the world of abstractions, from knowledge and math to morality. These are just theories like any else, and they have reach. This chapter is about the reach of theories and how some systems achieve a sudden jump to universal reach. chapter is divided into 4 parts. What are universal systems? How they reach universality? Are there hierarchies of universalities? What is a computational universality? And what is an evolutional universality? And the summary of the chapter is: our systems, like language or numerals, are theories of the world. They encode some regularity of nature. The deeper the regularity, the more the reach. Sometimes systems combine multiple regularities and reach universality. This is the jump to universality. Language got universality once it started using rules and digital systems like alphabet. Interestingly, systems that achieve universalities can have hierarchies depending on their efficiency of use. For instance, Tally Mark's system is universal, but it is less efficient than Hindu Arabic numerals. And to explain what you mean, so for instance, you have a number 375, and you see it on a blackboard in tally marks. Well, you'll have to count a bunch of tally marks. But if you see it as a Hindu Arabic number, it's just 375, you instantly can tell it. So the efficiency, the tractability, or the computation your brain requires is nearly instant with Hindu Arabic, while with tally marks, it couldn't take you quite some time. So they're higher efficiency and thus better universality for us humans because we have a limited amount of energy. Now moving on. To achieve universality of systems, we must encode in it some regularity of nature, that is, knowledge. Make it digital and don't put arbitrary upper bounds. We must understand that abstractions exist independently of physical matter, but they can be instantiated in it. Universality of computation is a powerful example that encoded profound regularity in nature. That regularity is computation. Computation is about calculating from inputs and output by following some specifically defined rules. And just as a side note, so if you define any computation like this, you input your message to the computer, then the output is that, let's say, they calculate what the multiplication of two numbers is. We all agree this is a computation, but if you really take this definition seriously, then universe is a computer. Universe has an input of a Big Bang, and output is what is currently calculating and what we see all around us. Like, I don't know, you walk on the street or you listen to this podcast, you hear the sound, the vibration of the waves, and this is the output of a computation. And the rules that it's using are the laws of physics. So it has a Big Bang, it is an input, it uses laws of physics to calculate what be an output. And the output is what you constantly see. And you can say that universe is a big computer that is calculating its own depth. And then tree is also a computer, which broke my mind for quite a while. It is a computer because the input is the sun, the soil, and all other minerals that trees use to grow. The rules that it's using are in its DNA. Its DNA and its genes are saying how to grow, what leaves to produce, do they fall or not, how tall it will go, and so on. And the output is the tree growing and doing photosynthesis and so on. So there are a bunch of things that are computers, but not everything. For instance, a rock wouldn't be a computer. And this is extremely powerful because basically computation is nearly like a law of physics. There are a bunch of applications to it. Moving on. There are computable and uncomputable numbers. Uncomputable numbers will never exist physically, but they exist in the abstract world. So as a side note, what does that mean? So uncomputable numbers, a number can be represented as anything. You can imagine a state of the universe. So for instance, we take this second and then this second and next second, and those are like several states. And each of those states can be represented as a number. You could say the state where you, for the first time, hear me say this word is a state 375. And there is the next state of the universe that is 378 when you hear this word. And it's only for the first time, not when you rehear it again. So those two states of universe can be represented as numbers. And then what does it mean uncomputable number or uncomputable? Computable is the one to which we can arrive through following some computations. So for instance, we can follow laws of physics and arrive at the number 375 in the way we defined it, or 378, but uncomputable ones would be the ones where no rules, regardless of time, will yield us such numbers. And if we take physics very seriously and computation as universe very seriously, this means that no laws of physics that we have right now will allow some universes to appear. An example would be going faster than speed of light. So our best understanding of physics and laws of physics is that one cannot go faster than speed of light. So any universe where something goes faster than speed of light is an uncomputable number. And then the next sentence we hear, uncomputable numbers will never exist physically, but they exist in abstract world. So the numbers or the universes where someone goes faster than speed of light can exist in the abstract world. Now we're moving on. Universal computer is a machine that can simulate any physical process because all physical processes are computations. Now again, pausing, this is a very important idea. So it's like Turing complete. So Turing proved that there can be a computer which can simulate any other computable function. And of course, we take the caveat that it has infinite time and memory. So what this means is that if the universe is a computer, there can be another computer that can simulate anything that is simulatable within the universe. But it is also that anything that is inside the universe can be simulated by some computer. So for instance, you and your brain are inside the universe, and your brain is obviously a computer that is running some computation, and obviously it can be simulated by other computer. And this we're following to our next sentence. Your brain would be one of such. And hence AI is possible. Side note, David uses AI as we would use now. AGI, basically it is a normal human brain, conscious, intelligent, and you just put it on a computer. And obviously you can put it on a computer if you take seriously that Turing proved the universality of computation. Moving on. Evolution seems to achieve some sort of universality with DNA. Interestingly, it is also a digital system because again it's ACTG. This is a side note. Yet, we can't explain which regularity it has encoded and why it stopped there. This is a problem yet to be solved by science. Chapter 7, Artificial Creativity. We touched upon knowledge creation, evolution, and computation. Specifically, we have talked about how computers can simulate human brain. Why then we haven't done it yet? This problem turns out to be harder than expected. It also doesn't help that most AI researchers, just as most physicists, have been led astray by bad philosophy. This chapter's main questions are: what is the Turing test and its mistake? How could we know whether something is AI or not? What is behaviorism? How it misled AI researchers for years? What is an artificial evolution? An important side note is that here again David uses AI, which we nowadays refer to as AGI, right? A machine that is conscious and intelligent just like humans. So again, you take a human brain, put it in a computer, that's an AI. And the summary of 7th chapter is: we know from universality of computation that it is possible to simulate human brain. We can create an intelligent machine that is just like humans. Turing test was the first attempt to test whether a machine is intelligent or not. If machine could fool you into believing it is human, then it was intelligent. This is a bad test because it is empirical. And as a side note, just imagine all those people who were already fooled, not even the ChatGPT times, but the Eliza times. So it was a chatbot Eliza, which would just basically, depending on what you say in some words, it would just choose out of an array of answers one and give it back to you. Some people were fooled by it being intelligent, but of course it's not. It's just a machine that just chooses out of the array. And same criticism would hold for ChatGPT. Just because it seems to be intelligent or conscious doesn't mean that it is. Again, you need to look at the explanation of things. And the problem again with empirical is then when you look up at the stars, you see them as dim, small dots, which are cold and not big. But again, when you study properly stars, they're big, hot, and so moving on. To know whether a machine is intelligent or not, we would have to rely on good explanations. AI would have to create its own knowledge. We will rely on explanations to judge the source of created knowledge. Is it programmers or the machine itself? As a side note, here David says that the essence of humans is that they create knowledge, and if we can see that some machine creates their own knowledge that was not put there by humans, but actually was created by the machine itself, and again, we could judge that only based on explanation, then we can say it's intelligent consciousness. But of course, not really, as you can see by our next paragraph. Qualia, consciousness, and other attributes of intelligence are barriers to creating an AI. We first have to solve them, only then to encode it in a machine. If we can't program it, then we haven't understood it. As a side note, we don't yet have a proper theory of what is consciousness. And we could judge whether it's consciousness or not if we can properly program it in a machine. We can run it, then David would say, then you have understood it. And I would generally agree with this criterion. So when David says that something is consciousness when it creates knowledge, to a certain extent, but not really, because we, again, don't have the theory of consciousness. Maybe it doesn't really have to do anything with knowledge creation. So we first need to figure out what qualia and consciousness is, and then talk about what is conscious or not. So when people ask, is ChatGPT conscious? Are animals conscious? Well, we don't have a theory of consciousness. We kind of generally agreed that humans have it, and kind of that's it. Moving on. Behaviorism is akin to instrumentalism and has misled researchers for years. Mimicking intelligence is not the same as being intelligent. Programmers giving the knowledge is not the same as a program creating it itself. Even in utilitarian terms, all the value lies in the second one. As a side note, one can say that ChatGPT only uses the knowledge that was given to it by the programmers. It only guesses the next token. The whole internet database of words was basically given to it and only predicts the next one. It is using the knowledge that is already within it and not a new one. Of course, some might say, but it created some text that was never seen. But the point that is that if it can really create new scientific knowledge better than the researchers themselves, all the value lies in it, not in just guessing sometimes next token and sounding convincing. Moving on, artificial evolution suffers from the same problem. Its knowledge is created by the programmers, not the program itself. David proposes an experiment to tell whether artificial evolution has actually worked or not. As a side note, David tries to make sure that no knowledge that was created by the programs passes to the computer itself, and we can securely say that the knowledge the program has created was done by it and not the programmers and so on. And you can read what the test is. It involves a robot and randomly generating the memory of the robot, basically, and having some errors, so repeating the evolution. Chapter 8, A Window on Infinity. We have talked about ideas that are closely related to infinities, rich of explanations, abstractions, computation, and so on. Yet, we haven't studied the infinities themselves. This chapter is about to fix it. It focuses on several topics. 1. What are properties of infinities? How do they work? And what is Cantor's argument? 2. What is the paradox of Zeno? What was its mistake? 3. How physics impacts what can be computed. How it impacts what can be proved in mathematics. 4. What all those physical limitations imply. What is the main limit of the knowledge creation? And its summary is: infinities are unintuitive. Every its number is extremely close to beginning. Side note, hence the beginning of infinity. Every number is extremely close to the beginning of infinity. None of them go far enough. Moving on, some infinities are larger than others. If we can create an algorithm to list every number of it, then it is countable. Otherwise, it is uncountable, which is bigger than the countable infinities. As a side note, it's a lot of countable and uncountable, but to explain what it means. So this is basically Cantor's argument. We know whether some infinity is equal to another by assigning one to another. So for instance, you take every positive integer and it would be 0, 1, 2, 3, and then you take every even number, it would be 0, 2, 4, 6, 8, so on. You can basically assign 0 to 0, 1 to 2, 2 to 4, 3 to 6, and basically you can go on like this. You can write a program which does it forever and so on. So they're equal. Yet, if you can't do this one-to-one assigning, then some infinity of it must be bigger than the other one. So uncountable infinities is the one where you don't even know where to start. So for instance, you take all real positive numbers. Where do you start? What is the smallest real positive number? You start 0.0000000 what? I can always add on another zero. You can say 0001. I say, well, why not add 10 more zeros? And we can go on like this forever. So there is never a starting point. So we can never assign it one-to-one. So all real positive numbers is a bigger infinite set. It is uncountable than the countable all positive integers, 1, 2, 3, 4, and so on. Moving on. Probabilities seem to change depending on how we shuffle the infinities. Hence, they don't work. And this is an important explanation. So imagine an infinity hotel. So basically hotel with infinite number of rooms. And David gives an example. Give his first book, The Fabric of Reality, to every millionth room. 1 million receives the fabric of reality. 2 million number on the room, right, receives the fabric of reality. All else receive beginning of infinity. So it seems intuitively to us that, it's very unlikely one gonna receive fabric of reality. It's 1 to a millionth likely. But now we do a shuffle and we say, well, actually, we change our mind. Actually, every even number gets beginning of infinity. Every odd number gets the fabric of reality. So what you get is now 50-50, seems like. And again, this is totally possible because we have infinite number of rooms. There are like infinite number of millionth. So we can just reshuffle them. And now what? We get 50-50. This is a problem because depending on how we shuffle the infinities, the probability seems to get entirely different results. So moving on, this is a refutation of the anthropic argument for solving the fine-tuning problem. Depending on how you present the infinity of universes with different laws of physics, astrophysicists would be more or less likely. I won't go into fine-tuning rabbit hole. You can definitely read it in the worksheet. I did a tree diagram for it because it's quite hard. Definitely check it out. So moving on. Paradox of Zeno is no paradox at all. It is a mistake of confusing an abstract mathematical infinity with the real physical one. These are two different things that are interlinked but exist independently. Immanuel Kant made a similar mistake of applying abstract geometry to the physical world and trying to derive some conclusions from it. Through the window of physical world, we can observe the abstract one. Laws of physics determine what is computed or not. Some mathematical functions seem simple to us only because our laws of physics are predisposed to it. Mathematical proof is just a computation. You derive output from input by following some specific rules. Computable and uncomputable things are defined by physics, and hence what can be proved and not in mathematics is the question of physics. But it should not undermine the existence of uncomputable things. They still exist abstractly, not just physically. Mathematical proof theory is a specific science, and its name is computer science. I mean, as a side note for this paragraph, basically, laws of physics determine what will be able to easily compute in mathematics or not, like how much time it will take or not. So, once again, as we've seen, if we think of universe as a computer, laws of physics are kind of just saying what can be easily computed or not. Well, some numbers, as we've seen, are incomputable. Basically, they're uncomputable just because of our laws of physics. Like if you shift a bit laws of physics, then the rules by which we'll play would be different. And then some numbers will become computable. So for instance, you change a bit laws of physics, all of a sudden, some things can go faster than speed of light, and then that might produce different results for what mathematical abstract things will be able to calculate. Some numbers will be uncomputable, and then all of a sudden, once we change the laws of physics, they become computable, as if, let's say, we introduce that something can go faster than the speed of light. So laws of physics go into the realm of mathematics and define what can be proved or not, what is computable or not. Moving on. Problems that are severely constrained by the laws of physics are usually too abstract, and thus uninteresting. Physics doesn't put severe limitations on our exploration of the world. One can't understand something without having a robust proof or computation to present. Knowledge creation is about creative thought and criticism. To claim it's about proof is to make a reductive mistake. Chapter 9, Optimism. We have explored many topics, but still not the essence of David's philosophy. Optimism chapter fixes it. Prepare to be excited. And its summary is: many public intellectuals like Martin Rees and Nick Bostrom make pessimistic predictions of humanity's survival in the next century. They make a mistake of trying to predict what knowledge will create in the future. But that's why it's a creation. We don't know it yet. So any probabilities that they assign to events are hopelessly wrong and will be changed by events they cannot foresee. Due to their pessimistic bias, they make pessimistic prediction. Anyone with optimistic bias can make the same mistake but arrive at a diametrically opposite conclusion. Obviously, both approaches are wrong. How then should we create policies for the future? So, as a side note to this paragraph, imagine one makes a prediction that, oh guys, I made a calculation and I'm going to run out of fossil fuels by 2050. And we can't really use nuclear power plants because, I don't know, they're unsafe. We don't produce enough wind and solar energy, so we are going to be in a very bad position, and actually we're going to have this huge crisis, right? And they say this is going to happen by 2070. The problem with all those 2070 predictions is that the person doesn't take into consideration that for the next 46 years, people can create knowledge. And for instance, they can solve nuclear fusion. And maybe nuclear fusion would give us much more energy, way more cheaply. And of course, when this person was running the calculation, they never took into consideration, maybe we figure out how to do nuclear power plants safe in their calculation. So they don't take all those potential knowledge creation into consideration, because again, they can't predict them. I mean, if you knew that general relativity would come after Newton, well, then you would already say, yeah, here it is, general relativity is better than Newton's. So that's a big mistake one makes when especially making very long run predictions, and it completely changes the probabilities one would use. So moving on. Policies are theories, and those are always guessed. We can never derive them. We guess them by making good explanations of the world. Trying to derive policies from something makes us think that there is better and worse source of knowledge, which makes political philosophy about who should rule question. This promotes violence, either for putting the right ruler in charge or suppressing its opposition so he can rule. This is wrong either way. There is no universally good source of knowledge. All our policies are just guesses, which are full of errors. Hence, political philosophy should be about how do we find and fix errors non-violently. As a side note, so if you can't really predict how the knowledge will grow and can't really make long-term predictions, first of all, it's quite interesting how this impacts, let's say, who you marry. Like, you can't really promise the person you're marrying you're going to stay with them whole life, because you don't know how the knowledge will grow, how the future will change. And with policies, it works that, okay, we don't really know how the future will play out, but we need to make some policies to account for the future. And people with wrong epistemological views would say, well, there is kind of some better source of knowledge. But again, we have already shown how this is wrong, because we have refuted like authority as a valuable source of knowledge. Like, just because he said it doesn't mean that all of a sudden it's true. There's no ultimate source of knowledge where whatever they say is true. So there are no kings which whatever the king says is correct. And we've had that mistake for quite a while now in history. So if you think that, oh no, this guy, he is the ultimate source of knowledge, he really knows what to do, then you'll justify it, or your explanation would be that, okay, then we can put him, and as he gets in power, then he'll solve all of our problems. Doesn't matter how we get there in the first place. So you say that violence is okay. And of course, this is wrong. I would also say, how can we fix errors as fast as possible, non-violently? Moving on. David summarizes the optimism part well. And this is again the quote. I rarely do that, but great quote. Page 221. Optimism, in the sense that I have advocated, is the theory that all failures, all evils, are due to insufficient knowledge. This is the key to the rational philosophy of the unknowable. It would be contentless if there were fundamental limitations to the creation of knowledge, but there are not. It would be false if there were field, especially philosophical field, such as morality, in which there would be no such thing as objective progress. But truth does exist in all those fields, and progress toward it is made by seeking good explanations. Problems are inevitable, because our knowledge will always be infinitely far from complete. Some problems are hard, but it is a mistake to confuse hard problems with problems unlikely to be solved. Problems are soluble, and each particular evil is a problem that can be solved. An optimistic civilization is open and not afraid to innovate, and is based on traditions of criticism. Its institutions keep improving, and the most important knowledge that they embody is knowledge of how to detect and eliminate errors. They may have been many short-lived enlightenments in history. Ours has been uniquely long-lived. And as a side note, of course, we determine whether it will be long-lived or not. We're not destined to progress forever, as we're not destined to fail. It is our fate and our choice of what to do it. Chapter 10. A Dream of Socrates. This is an easy chapter for David's standard. It is about the dialogue between Hermes and Socrates, and there is not a lot to summarize. Chapter's main focuses are 1. Are we fallible? 2. Can we derive knowledge from something? And 3. What should be the basis of morality? And its summary is, we are fallible and we can't escape it. Our senses, our thoughts, everything, all is fallible. We can't derive knowledge from anything. We can only guess and then criticize to improve. The basis of morality isn't preserving the means of error correction. They are the only way to progress. Constraining progress is immoral, for it prolongs suffering. As a side note, it's quite interesting. David long ago wrote an explanation for why actually the basis of morality is quite hard to tell, and regardless of what basis for morality you give, you actually will want to progress and do kind of the same. So for instance, let's say that your basis of morality is that you have to maximize the number of squirrels in the universe. How do you do that? You probably first establish proper means for humans to develop, you conquer the other galaxies, to use the resources enough to become sustainable, and not then try to create farms of squirrels. So any resource you use to create farms of squirrels, you'll not use to first make sure that humanity is super sustainable and will not go extinct in any way, so you can then focus on maximizing the number of squirrels. And actually, anything alike you'll give will be about, well, you first have to make sure that humanity is really sustainable, really good, and then move on to do something. So it's baseless morality, which leads, actually to the same outputs. Quite an interesting explanation. In this chapter, David explains what quantum physics implies if one takes it seriously, painting an astonishing world. Yet these are just our best explanations that we should take seriously to understand reality. Disclaimer: David presents a many universes interpretation of quantum theory, which is still a minority view among physicists. He explores why is it so in the next chapter, and spoiler, it is bad philosophy. Many universes is an interpretation of quantum physics just as much as dinosaurs are an interpretation of fossils. The summary of the chapter is: familiar to us, universes are an emergent phenomena of the multiverse. They appear to be autonomous, but when studying behavior of the smallest things, like particles, one must invoke multiverse as an explanation. So as a side note, basically there is an interferometer experiment and a double slit experiment. I'll definitely make a YouTube video and talk about the quantum physics and how you could only explain what happens in those experiments reasonably while invoking the multiverse. But sometimes photons don't do what they're supposed to do if there's just one of them, and only to explain what they do you have to say, well, there are actually a bunch of photons and they interact with each other and so on, but we cannot see them, and yet they influence the ones we can see. And I won't go more into details, this is a very big rabbit hole. Moving on. Within multiverse, any particle is actually a fungible group of infinite particles. All particles are constantly merging and splitting within its multiverse counterparts. All objects are made of particles. Hence, any object is actually a fungible group of infinite objects. So, as a side explanation, you can't say that just, oh, look, the photons act weird, and actually any other atom also acts weird, and we have to invoke the multiverse explanation, but we can't say, well, it works for atoms and photons, but it doesn't work for us humans, or it doesn't work for the computer, or the headphones, or the things you're listening on. Those are different atoms, those are different photons. You can't extrapolate the explanations on bigger objects. But of course you can. Of course, the bigger objects are made out of smaller objects called atoms. And of course, atoms are no different when we look at the experiment of them. They're the same atoms and the same photons. So we should be brave enough to extrapolate on all the things around. And you say, well, actually you as a human and you and the computer you're listening are infinite, fungible group of things, and you're constantly splitting and merging, but of course you can't not really tell it, and I'll save it for the viewer to research further. Again, a very short summary. So moving on. Entanglement information explains why we don't constantly observe splitting and merging of bigger objects and particles. Fungibility explains how laws of physics could be deterministic, yet cause differentiation within the multiverse. So, side note, so it's quite interesting. So, laws of physics are at one deterministic, but at two purely random. When we look at quantum physics, so let's say you have double slit experiment, we kind of cannot tell where exactly on the palette the photon will arrive. We know that some areas it will never arrive, and yet we don't. So let's say there are like 3 possible areas a photon could arrive when we fire it. We know that it cannot be anywhere but those 3 areas. We never observed it anywhere but those 3 areas, but we can never tell would it be in the first, second, or third area. This is something we can never predict, and no explanation can help us. So it's like kind of purely deterministic, purely random, but again, purely deterministic, that it will be always in one of those three areas and nowhere else. So, a quote from page 304. The physical world is a multiverse, and its structure is determined by how information flows in it. In many regions of the multiverse, information flows in quasi-autonomous streams called histories, one of which we call our universe. Universes approximately obey the laws of classical, pre-quantum physics, but we know of the rest of the multiverse and can test the laws of quantum physics because of the phenomenon of quantum interference. Thus, a universe is not an exact, but an emergent feature of the multiverse. One of the most unfamiliar and counterintuitive things about the multiverse is fungibility. The laws of motion of the multiverse are deterministic, and apparent randomness is due to initially fungible instances of objects becoming different. In quantum physics, variables are typically discrete, and how they change from one value to another is a multiversal process involving interference and fungibility. Of course, the summary does absolutely no justice to the whole chapter. Very complex chapter. You have to research on your own. This is a must-have. You just use everything you have. Book, Brett Hall, the Multiverse playlist, the questions in the flashcard I have created. Get all the help you need. Chapter 12. A Physicist's History of Bad Philosophy. If multiverse is the only satisfactory explanation of quantum physics experiments, why only a minority of physicists have embraced it? Bad philosophy is the answer, specifically explanationless science. And the summary of this chapter: explanationless science is impossible, for we always have implicit theories of the world to navigate life. Popper has shown it. All observation is theory-laden. Explanationless science is actually about hiding your implicit theories, keeping them immune from criticism, and hence delaying the growth of knowledge. Therefore, most explanationless studies will just reveal correlations, for causations require an explanation, and give implicit support to our implicit biased theories of the world. By giving such rational basis to our parochial rules of thumb theories of the world, we get further imprisoned in them, accepting such nonsense as that slavery is genetically determined. Explanation science makes it easy to fool ourselves. As a side note, Richard Feynman saying that science is the best way we have figured out how not to fool ourselves, and with genes, just to explain what the problem is with explanation in science, imagine looking basically 200 years ago and you do a study and you see that there is a very strong correlation with black people being slaves. And you're like, okay, well, it seems like there's nothing we can do here. It's just a law of nature. I mean, look at this strong correlation. And you wouldn't bother to think that, oh, maybe if we change our political institutions, we'll be able to combat that. Maybe that's not a law of physics. And of course, the core is that you actually chose to look at the fact that people are black. So you could have chosen an infinite number of variables and theories that would correlate with people being slaves. So for instance, you can say, oh, look, there is a huge correlation of people not getting tan and being slaves. So anyone who doesn't get a tan is basically determined to be a slave. And of course, not get a tan because they're black. And this is kind of why the idea that all observation is theory-related and so important. Because if you just can purely go in the world and observe whatever you see around, then, well, it can't work like this, because you have limited energy capacity and you have limited focus. You choose on which specific variables to focus on. So, as a famous example is of the Michelson, who was 30 or 20 years before the Einstein have discovered the general relativity, was conducting and observing specifically the same experiments as were the fundament for Einstein proving and thinking of general relativity in the first place, right? So why would Michelson observe the same experiment and yet have not arrived at the theory? Maybe because his implicit theories were wrong. Maybe because knowledge creation is not about conceiving your mind out of all the preconceptions and biases, making it pure and just noticing, inducing the theories around you. So then moving on. Yet, bad philosophy actively prevents growth of knowledge, not merely delays it. Explanationless science incentivizes scientists to make mistakes in observation, and its suggestive interpretation because it yields more exciting results. Thus, it actively promotes error correction, the opposite of good science. The best ways to oppose exponential science is through bold, willful progress. Chapter 13. Choices. As optimists, we would want the progress to continue indefinitely. Hence, the questions are: how to design a society that maximizes progress? How to make social decisions? Is there a source of knowledge that we could use? David starts with the narrow problem of apportionment, proceeds more universally with group decision making, and finishes with a decisive conclusion on how to make decisions as a society. The summary is: decision making is an act of creating options, explanations of the world, and choosing between them through criticism. All decision making is about knowledge creation, knowledge of which options to have and which to choose. Be it scientific or societal issues, knowledge creation process is universal. Hence, to run society rationally, we must apply our best epistemological theories to it. There is no source of knowledge we could access individually or collectively. We can only guess, that is, conjecture, solutions to our problems and criticize them. The better political system is at testing our best solutions and removing the broken ones without violence, the better political system it universally is. So as a side note, you want to promote political systems that are great at testing our best solutions. An important idea is, for instance, compromise, which we'll talk about in a second, and how bad it actually is, and removing the solutions that don't work and trying another that might work, and doing so without violence. So moving on. For this reason, plurality voting systems are better than proportional representation ones. They consensus power in one party, which allows it to implement its best solution to the problem, not an average of several options no one would choose in the first place. Failure of the tested solution would have real repercussions, loss of power entirely. So to explain the argument, we have a problem and we want to test our solution. So let's say I think of solution X, you think of solution Y, and then we have to decide. Say we use compromise and we're like, well, let's do middle ground. Let's not do X and not do Y, let's do Z. Say we do Z, we test it, turns out it doesn't work. What do we do next? Like, what have we learned? Well, first of all, none of us in the first place thought that Z was the best option. No one wanted the Z. And no one thought it would work. So when it doesn't work, I'll just say, well, it's because you haven't tried X. You say it's because we haven't tried Y. And so no one learns anything. But if we try my method and it doesn't work, then first of all, the voters will vote me out and I'll have real repercussions because I'll lose my power and you'll be able to test Y. So we'll know that X doesn't work. Let's say your Y also doesn't work. Then we won't try to do X and Y again. We'll try then maybe W, maybe S, and so on. So other options. And we'll learn on them trying to repeat. Moving on. Not only proportional representation gives the most power to the third largest party, it mainly relies on compromise, an erroneous theory of how knowledge creation works. If full decision making is knowledge creation, does anyone expect an average of the two options to work for science? Do we get the mean of Newtonian and Einsteinian theories to progress? No. So why expect this to work for decision making? As a side note, well, of course, when we have, let's say, Einsteinian and Newtonian physics, and we have to test and figure out which one is the right one, we didn't say, well, guys, let's not fight. Let's just do the middle ground and just go moving on, right? Like Einstein says the stars will be here. Newtonian says stars will be there. Let's take 50-50. Let's do somewhere in the middle ground and just move on. Like, this would be outrageous. And of course, this is for science, this is for knowledge creation, but decision making works exactly the same. It's about creating the knowledge, and so compromise should be entirely out. And as a super side note, person who's super interested in business, Jeff Bezos would be the biggest proponent of disagree but commit. You don't want to use compromises. It's bad. So if you don't agree with someone, you want to say, okay, I disagree, but I'll commit and we'll try your option fully and then see how it goes. So it's quite interesting how I saw it in David, and then long before that I've studied it and saw it in Jeff Bezos. It was a great idea. Chapter 14. Why are flowers beautiful? Is there an objective beauty? Can we create knowledge about abstract phenomena like philosophy and aesthetics? Summary of the chapter. People believe that we can't create knowledge about abstract phenomena because we can't sense them. They're abstract, not physical. Thankfully, we don't derive knowledge from our senses. We guess theories and criticize them, choosing the last man standing. Obviously, we can create theories about abstract things. All our theories are explanations. Explanations can rely on physical things, which certainly can be wrong. Hence, the entire explanation can be wrong. It doesn't matter whether the explanation is about an abstract or physical phenomena. If there is wrong, there is right. There is better and worse. There is objectivity. Thus, there is objectivity in abstractions. Just as one can be mathematically wrong, one can have wrong moral and aesthetic theories. As a side note, once again, I think the example was 9/11, perfectly showing what we're talking about here. When people say, well, I don't think it's really objective, you really have to say that if you think something is purely subjective, there is never, better or worse, that absolutely unequal. All is uncomparable. There's not even a sliver of difference between two things. Because even if there is a sliver of difference between two things, you can imagine a more sliver and a more, so you can improve and you can be really worse. And then you can get really right and really wrong. And all of a sudden, if you allow even a sliver of improvement, of progress, of difference, you allow the entire objectivity to exist. So it's very important to remember. So, if something is a regularity in nature, there must be an explanation for it. It can't be just a coincidence. Science searches for such explanations. Chapter 15. The evolution of culture. We have considered what is the most rational way to make decisions as a society, yet regardless of arguments, our culture decides whether we follow them or not. Hence, 1. What is culture and what are the memes? 2. What are types of societies? 3. What are types of memes? And 4. What social norms endorse knowledge creation? And this is the summary. Culture is a collection of memes, explicit and implicit. Memes, just as genes are replicators. Meme type is defined by how it replicates. Rational memes survive by being useful to their holders because they are deep truths of reality. They stay alive by promoting criticisms of themselves and their rivals. They evolve towards deeper truths of reality. Anti-rational memes survive by disabling creativity in their holders. They suppress critical thinking and abuse human shortcomings to stay alive. They evolve further away from deep truths. If society is dominated by rational memes, it is dynamic. If by anti-rational ones, it is static. Hence, static societies have a barely visible progress to their inhabitants. The only thing that is stable in dynamic society is progress. Western democratic societies are young, dynamic societies. Only partial areas of it are dominated by rational memes, like physical sciences. Other areas, like gender preconceptions or societal norms, aren't. Consider the societal repercussions a man would have by putting some paint on their face. That is, lip balm. Side note, specifically red lip balm or putting some makeup. To continue, such reaction doesn't withstand any criticism. Side note, of course, a lot of people in our society all of a sudden would start reacting to it like, oh my god, what have they done? They would perceive the man as weird, but all of a sudden, because a woman has different genome, that is okay. There's no rational basis for it, and it's just showing how some parts of our society is still dominated by anti-rational memes. Moving on. Noticing anti-rational memes is hard, because their evolution optimizes for it. Side note, it optimizes for hiding. Moving on, one should be worrisome whenever coercion or authority appeal is present, for somewhere around must be anti-rational memes. Noticing such memes is the hardest part. Eliminating them would take only a sliver of criticism. As a side comment, an amazing question I've seen is to ask oneself, what are my most important beliefs? And what are the most fundamental, the most impactful, and trying to debunk them. How much time have you spent debunking them? Are you sure they're not hiding as anti-rational memes? In general, I think it's quite important to spend a lot of time on your most important beliefs and try to debunk them. Of course, I'm just striving for that. And with anti-rational memes, just asking yourself, what are my anti-rational memes? Trying to make them visible, it destroys them because you just have to shed light on them and they will disappear because they survive by hiding, not by being able to withstand any level of criticism. Chapter 16. The evolution of creativity. We have evolved to be creative. This is what makes us unique. This is why we have landed a man on the moon and have zoos with us as visitors, not inhabitants. Yet, innovation can't be an evolutionary pressure. For our tools were evolving only every thousands of years. What use was creativity? What was the evolutionary pressure for it? And the summary of the chapter and the answer to those questions are: there was an evolutionary pressure for creativity not because it yields innovation, but because we use it to understand and replicate memes. Those that better understood societal norms adhered better and were sexually rewarded, hence the evolutionary pressure. Ability to innovate is just a luck byproduct of understanding societal norms. For understanding nature is about the same problem of finding a hidden explanation. Understanding societal norms cannot be done through induction or any other deriving from external environment. Just as with scientific knowledge, it is about guessing and criticizing. Knowledge always comes from the individual, not into them. Side note, repeating, knowledge comes from the individual, so you create the knowledge, you guess it, and not into them. Not, you force themselves into. You can just pour them into the person. Again, they have to always guess. So moving on, even reading a book isn't about putting knowledge into you. All the understanding that you get comes from within you, from your guesses and explanations about the book's content. So, of course, this is true and the same of this podcast. Of course, none of what I'm saying to you, I'm pouring directly into you. All I'm saying and all the knowledge you will get from this podcast is about you being able to guess the theories. You are guessing the meaning of my words, how I'll use them, in what context I'll use them, and how altogether they form some idea. This is all done on your end. And if you're doing it passively, you won't really learn. And this is why, small rant here, it is so important to use the flashcard and the question-based framework. And that's why literally the studies show 50% more efficient results for students and anyone else, is because people challenge themselves. People try to explain to themselves. They are becoming active instead of passive. And of course, it yields greater results. Chapter 17, Unsustainable. What is sustainable? There hasn't been a better time to be born than nowadays. Yet, do we want to sustain such lifestyle? Do we want to forever engrave our current mistakes? Or do we want to correct them? Sustainability, in the parochial sense, can never be sustained. It will be crushed by first unforeseeable problems. What then must be the desired policy? How can we sustain ourselves? And the summary is: sustainability in keeping the things as they are is a mistake. What will we sustain? Our current mistakes? Mortality, slavery, and starvation? Even if one desires to engrave nowadays lifestyle, the good resource management can't be a solution, for it solves existing problems and not unexpected ones. For instance, like COVID. We recently figured out that the Earth will become a red giant and boil all the oceans in a few billions of years. And it's actually a big problem, or that the global warming is actually a big problem. Like, if we take 200 years before that, we did not know that. So if we try to sustain our 200-year before lifestyle, we would never be able to find out those problems and prepare for them. The sun will still be there and it will still boil all the oceans in a few billions of years, become red giant and consume all the Earth. That will certainly happen with our best understanding of laws of physics, so we might as well progress to prevent that happening. So yeah, but again, we can only prepare by progress. So moving on, the only thing that is sustainable is progress. No policy escapes problems, so we must choose one that deals with them in the best way. Progress and increase of wealth will always put us at the best possible position to deal with problems. How do we increase wealth? By promoting knowledge creation and hence people. Each person is a universal constructor, a lottery ticket to solve some important problem. To survive, we need more wealth, we need more knowledge, and we need more people. Progress is the only sustainable option. A side note, an explanation. Imagine you want to prepare yourself to prevent humanity from extincting. What would be your best policy? Would you try to revert the progress or try to consume less of the things to solve, let's say, the global warming? Well, the answer is no, because you don't know what the other existential risk will face. So the best thing you can do is to grow our wealth, and the wealth here is defined as possible physical transformations we can do. So for instance, we can transform entire galaxy, or decide to take all the sun's energy and so on, or deflect a meteor if it hits us. Actually, there was a study showing that we can't really deflect a meteor if it now hits us, which is quite interesting. I would always assume it we could. But oh well, turns out we can't. So the better option would be to prepare and grow our wealth, progress, so we can deflect the meteor, deflect when the sun will become a red giant in a few billions of years, boil our ocean, and make sure that it doesn't do so, and so on and so on, right? So even the global warming, the favorite example of everyone of why we should stop progressing or we should pause a bit, you see, global warming will be solved by some technology, like technology of taking carbon dioxide from the atmosphere. It won't be solved by trying to cut and go against the human nature. My personal belief is that it's definitely hard to go against human nature, so you might as well go along with it, figure out the incentive system that goes for the good and for the benefit of everyone else while using human nature. There's nothing wrong with it. You just gotta apply it in the right way. Chapter 18, The Beginning. And this is the quote of Winston Churchill. Of course, I took it from Brett Hall. I just absolutely loved the quote. Oh, this is not an end. This is not even the beginning of the end, but it is perhaps the end of the beginning. And the summary of the chapter is, it is up to us, humans, to decide whether we engrave our current lifestyle, whether we imprison ourselves in the parochial errors of mortality, starvation, and slavery, or we correct errors, we progress and explore the stars, the universe, and everything. We have all the tools we need. Everything that isn't prohibited by the laws of physics is possible. And in fact, it has happened somewhere in the multiverse. The question is, which one of these universes you will choose to be in? And I want to end this podcast with just reading the last 2 paragraphs of the book. Our world is so much larger and more unified, more intricate, and more beautiful than that of Aristophanes, and which we understand and control to an extent that would have seemed godlike to him, is nevertheless just as mysterious, yet open to us as his was to him then. We have lit only a few candles here and there. We can cower in their parochial light until something beyond our ken snuffs us out, or we can resist. We already see that we do not live in a senseless world. The laws of physics make sense. The world is explicable. There are higher levels of emergence and higher levels of explanation. Profound abstractions in mathematics, morality, and aesthetics are accessible to us. Ideas of tremendous reach are possible. But there is also plenty in the world that does not and will not make sense until we ourselves work out how to rectify it. Death does not make sense. Stagnation does not make sense. A bubble of sense within endless senselessness does not make sense. Whether the world ultimately does make sense will depend on how people, the likes of us, choose to think and act. Many people have an aversion to infinity of various kinds, but there are some things that we do not have a choice about. There is only one way of thinking that is capable of making progress or of surviving in the long run, and that is the way of seeking good explanations through creativity and criticism. What lies ahead of us is in any case infinity. All we can choose is whether it is an infinity of ignorance or of knowledge, wrong or right, death or life.